Good morning, students. Today we are going to solve miscellaneous exercise on chapter number 5. Chapter number 5 ki miscellaneous exercises solve tausiko. Number 1, evaluate I to the power 18 plus 1 by I whole to the power 25 and whole to the power 13. Se evaluate tawgadav. Evaluate means step expression je a plus ib the thamgadav ko. Question number 1. I to the power 18 plus 1 by I to the power 25 whole to the power 3. Koina I gi power se reduce to vi ko. Every powers of I can be reduced to I plus 1 and minus 1 the reduce to. See 18 je 2 square whole to the power 9 the thumb by ko. 18 is the multiple of 2. It can be expressed as I square whole to the power 9 plus. Then 1 by I whole to the power 25 is equal to 1 by I to the power 25 whole to the power 3. This minus I square is replaced by minus 1 to the power 9 plus I to the power 25 is odd number. So we should multiply denominator and numerator by another I. We have I divided by I to the power 16 whole to the power 3. I to the power minus 9 even odd or minus 1 fange I divided by this I to the power 23 can be expressed as I square whole to the power 13 and whole cube equals to minus 1 plus I divided by replace I square by minus 1 whole to the power 13 whole cube minus 1 whole cube se otabagi minus sign amlaani minus I whole to the power 3. Then taking minus 1 common from this expression, we have minus 1 whole cube and 1 plus I whole cube. Then expand the expression of 1 plus I whole cube by using the formula a plus b whole cube. A plus b whole cube use tawraga koina si expand tawsiko. Minus 1 whole cube is equal to minus 1. 1 plus I whole cube is 1 cube plus 3 times of 1 square I plus 3 dot I square plus I to the power 3. Si fange ko 1 cube is 1 and 3 1 square is 1 3i 3 1 1 fange ko 3 fange duga value of I square gi minus 1 amaga minus 3 I cube is reduced to I square into I sumani ibe ko. Then this I square is reduced to minus 1 duga plus c ga si minus 3 ga minus 2 tare ko. Si minus 2 ere minus sign am lejare minus 2 3i minus I di 2i tare ko. Minus 2 plus 2i multiply by this minus 1 is equal to 2 minus 2i. Masagi nangona pyramid expression ja kaigi form the reduce to where 2 minus 2i, which is a complex number. Real part is plus 2 and imaginary part is minus 2. Nangi powers of I se koina powers of I gi rule mayam do use tawraga sum reduce tawrani ko. Aduga aroibagi expression se a plus ib da thamna honaba. Next question number 3. Reduce 1 divided by 1 minus 4i minus 2 divided by 1 plus I into 3 minus 4i divided by 5 plus I to the standard form. Standard form I di kaino a plus ib the thammo haiba ko. Question number 3. The given expression is 1 divided by 1 minus 4i minus 2 divided by 1 plus I, and the second expression is 3 minus 4i divided by 5 plus I ni ko. Sigi first ki term sidagi LCM lause. LCM of 1 minus 4i and 1 plus I. They are of different factors, so their LCM is product of these two factors, 1 minus 4i into 1 plus I. Then multiply this 1 by 1 plus I and multiply this 2 by 1 minus 4i na multiply tawtare ko. 1 plus I, 1 minus 4i multiply by minus 2 minus plus tare ko. I divided by 1 minus 4i into 1 plus I into expression je ire. 1 ga sige minus 2 ga di. Then find the sum of real part and imaginary part. 1 minus 2 gi minus 1 am pange ko. Sige I sige 8i sige di 9i am pange divided by find the product of these two complex number. 1 into 1 is 1. 1 into I is equal to I. Minus 4i into 1 is minus 4i. Minus plus di minus sige minus siga sige plus 1 ga di minus 4 tare ko. And I square, value of I square is equal to minus 1 into write the second expression. Second expression je dum irasi ko. Minus 1 plus 9i divided by minus plus this 4 plus 1 is 5 tare. I minus 4i is equal to minus 3i multiplied by 3 minus 4i into 5 plus I. Sumain taraga sisu complex number se rational gi form na chale sisu rational gi form na chale ko adudi mathak makha mu product lower se find the sum of numerator and find the sum of denominator. Numerator na numerator gi sum, denominator na denominator gi sum hole sika. Product hole minus 1 into 3 minus 4i minus 1 hana multiply tawro minus 3 plus 4i plus aduga 9i na multiply tawro di 27i 9 into minus 4 is minus 36 and I into I is equal to I square. I into I say I square tareko. And this 5 minus 3i into 5 plus I. See multiply already 5 25 tareko. 5 ki 25 ama 5 into I is equal to 5i minus 3 into 5 sigina minus 15i am pange. Tuga minus 3i into I have a second itani. 3i into I is equal to minus 3i whole square. See mathaki sida minus 3 ko. Minus 36 value of I square is equal to minus 1 minus plus dare minus 3 plus 36 ko 4i plus 27i is equal to 31i. The ginang denominators dena minus 3 into minus 1 is equal to plus 3. So 25 plus 3 is equal to 28 are. Then 5i minus 15i. 5i dagi 15i lagthokradi minus 10i sen phange ko. Nangi kasagi expression se 33 plus 31i by 28 minus 10i da thamba yare. Adu di sigi mo ko na rationalize tawsika. Rationalize the complex number in denominator. Denominator the rationalize tawbadi minus layer magadi plus na multiply tawrani. 33 plus 31i, 28 plus 10i divided by 28 minus 10i, 28 plus 10i suma ireko. Denominator say a square minus b square ki form da chale. To find the product of these two complex number. 33 into 28, 924. 33 into 10i, 330i. 31i into 28 is 868i. 31i into 10i is 310 I square lereko. Then for denominator 28 square minus 10 square and I square. Then separate real part and imaginary part by putting I square is equal to minus 1. 924 minus 310 plus, and the sum of these two numbers is equal to 198. I am happening. I is the imaginary number. 784 plus 100 fange. 28 square is 784 and 10 square is equal to 100 and value of I square is equal to minus 1 minus plus tareko. Difference of real part 614 and imaginary part 1198i divided by sum puthodi 884 niko, and dividing 307 by 442 and also dividing this 955. 614 plus 1198i da 884 niko. Sigi number ma'am se 2 na loin divide away 2 na hana divide tokse. Divide 614 by 2 is equal to 307. 1198 by 2 is equal to 599 I tareko. Tugi 884 da 2 na divide tok tadi 442 se fange. Then write 307 by 442 plus 599 I by 442, which is of the form a plus ib. A plus ib ki form the lereko. To namase standard form the label kore. Next question is question number 5. Convert the following in the polar form. Polar form the r cos theta plus r sin theta duko. Adui mong the chat pase polar form ne. Number 1 gi 1 plus 7i divided by 2 minus I have. 1 plus 7i the 2 minus I gi square na. Divide over ko. 1 plus 7i divided by 2 minus I whole square. First expand 2 minus I square by using the formula a minus b whole square. 1 plus 7i 4 minus 2 into 2i plus I square. 1 plus 7i 4 got 2 into 2 4i. Value of I square is equal to minus 1. 1 plus 7i 4 plus minus 1 is equal to 3 and minus 4i. Later ko the 3 minus 4i is a complex number and the minus part o itar disi and rationalize tawsiko. Si rationalize tawbo kanda minus layer the plus the multiply tower. multiplying denominator and numerator by 3 plus 4i. Then find the sum of this product. 3 plus 4i, 7i na multiply already, 21i plus 7 into 4 is equal to 28i into I is equal to I square. And which is of the form a plus b, a minus b is equal to a square minus b square equals to 28i square. By putting I square is equal to minus 1, we have 3 minus 28 is minus 25, and 4 plus 21 is equal to 25i, and 9 plus 16, 25 tare ko. Jadi nang gisigi complex number sa kaida reduce tore. Question number 5 ki minus 25 plus 25i, that 25 na divide out tardi, the given complex number is reduced to minus 1 plus I, the reduced out ra. And let this complex number be equal to x plus iy, the koina magamana hale ko. X is the real part is equal to minus 1, and imaginary part y is equal to 1. Real part na minus 1 tare, imaginary part na plus 1 tare ko. First find r. R is given by modulus of z. Modulus of z is equal to root over x square plus y square, real part ki square plus imaginary part ki square ko. 1 square 1, 1 square 1, and their sum is root over 2. Then find 10 alpha. Koina argument haibam sutam gi ko. 10 alpha ki value se kaina piwa modulus of y by modulus of x. 1 1 1 tare, dudi 10 alpha na 1 tawase karamba angle da tai haitar di alpha sina pi by 4 oirakanda. Since the point P, x comma y, here value of x minus 1 and value of y is equal to plus 1. First check the sign of these coordinates. X negative, y positive. Minus 1 comma plus 1 will belong to the second quadrant. Second quadrant the layer ko. And therefore, the argument of the complex number is given by pi minus alpha, which is equal to pi minus pi by 4. Gonna solve already. 3 pi by 4 tare ko. 3 pi by 4 is the argument of the given complex number, and the modulus of the complex number is root over 2. And therefore, the polar form of the complex number z is given by r cos theta plus I sin theta. Then substitute the values of r and theta in this expression. R is represented by root 2, and this theta is to be replaced by 3 pi by 4 plus I sin 3 pi by 4. So my replace the and this is the polar form of the given complex number. Nanguna sai p giba complex number dogi polar form sa si tarani. Next question is question number 10. Question number 10, if z1 is equal to 2 minus I and z2 is equal to 1 plus I, then find modulus of z1 plus z2 plus 1 divided by z1 minus z2 plus 1. z1 plus z2 plus 1 da z1 minus z2 plus 1 na divide over dugi modulus puto o hai baka. Modulus se kamay puto kani. Question number 10, z1 is equal to 2 minus I and z2 is equal to 1 minus I. z1 na 2 minus I pire, z2 sina 1 plus I pire ko. Doi tardi sigi modulus ki da z1 plus z2 plus 1 haiba expression ama, denominator dana z1 minus z2 plus 1 haiba expression ama ko. First ki z1 iro 2 minus I, z2 ki value na 1 plus I plus 1 tare ko. Then for denominator, first write z1 2 minus I and z2 minus some later 1 plus I plus 1 tare. Chitaraba matungda koina kaidawni haradi 2 plus 2 minus 0. 2 minus I minus the bracket open taradi minus 1 minus I plus 1 pangeko. Sida kana cancel to I harakan sigi plus 1 siga minus 1 cancel taradi 2 minus 2 I have se pangani. 2 minus 2 I se pang taragadi 4. Modulus of 2 minus 2i sigi expression sigi di nangi plus I ga minus I ga kakrani. 2 siga 2 siga 2 siga di kya tare 4 oina fange ko. 4 fange 4 gi modulus lawbadi dum plus 4 tazare. Madi real part katang exist tawre, imaginary part se exist tawre ko. root over 2 minus 2i sigi 2 gi real part ama imaginary part ki minus 2 si symbol se kaino modulus neba modulus of the complex number haita the root over real part ki square plus imaginary part ki square ni ko 4 divided by root over 4 plus 4 divided by root over 8 which is equal to 4 divided by 8 can be expressed as 2 square into 2 divided by 4 by 2 root 2 2 ka equal 2 divided by root 2 tare. Then this 2 can be expressed as root 2 whole square, and this root 2 whole square divided by root 2 we have root 2. Root 2 is the value of the expression modulus of z1 plus z2 plus 1 divided by z1 minus z2 plus 1 hai ba nangi question sigi expression sigi value ni ko. Next question is question number 11. If a plus ib is equal to x plus I whole square divided by 2 times of x square plus 1, then prove that nangna prove tawdu se kaino. Then prove that a square plus b square is equal to x square plus 1 whole square divided by 2 times of x square plus 1 whole square ni ko. A plus ib से x plus I whole square divided by 2 times of x square plus 1 ga mana taragadi a square plus b square से sigi expression से ga mana na semba ko. Question number 11 we have a plus ib is equal to x plus I whole square divided by 2 times of x square plus 1 sipire ko. And then we shall prove that a square plus b square is x square plus 1 whole square divided by 2 times of x square plus 1 whole square ni. Sigi a plus ib the a square plus b square lakpa haibase modulus lawrakanda khaktang lakadamni ko. Now taking modulus on both sides of the equation. Modulus habe ko modulus of x plus I whole square by 2x square plus 1. Modulus of x plus I whole square by 2x square plus 1 is equal to modulus of x plus I whole square divided by modulus of 2 times of x plus 1. Si kaiday laino by the result of modulus property ni ko. Then modulus of a plus ib is equal to root over real part square plus imaginary part square a square plus b square tare. Then modulus, then expand this expression x plus I whole square. Si expand to x square plus 2 times of x I plus I square divided by 2 times of x square plus 1. Since 2x square plus 1 is any expression, real number expression tare I yaudeva ko. X square value of I square is equal to minus 1 plus imaginary part is 2xi tipire ko divided by 2x square plus 1 root over a square plus b square is equal to modulus law haiba. Modulus of x square minus 1 plus 2xi sina real part tare sina imaginary part tare ko which is equal to root over x square minus 1 whole square plus 2 times of x whole square divided by 2x square plus 1 ji ore. Sina real part square piba sina imaginary part square piba ko root over a square plus b square is equal to root over x square minus 1 whole square expand over dx to the power 4 minus 2 times of x square plus 1 plus 4x square tare ko and 2x square plus 1 later root over a square plus b square se root over sigi x to the power 4 se x square square aina thamba yare ko sigi minus 2x square siga 4x square siga koina difference puthok taragadi 2x square fange 1 am fange sigi expansion je kanagi expression kanagi expand gi la ino hai taradi x square plus 1 whole square hai sigi expansion type tare ko stasu root yaw stasu root yawdra root manghan ge hai taradi kaidongne sigi 2 siga root siga budi cancel tawre ko we have x square plus 1 divided by 2 times of x square plus 1 je fange. Then to eliminate this square root from a square plus b square we have to square on both sides of the equation. Now we get a square plus b square is equal to x square plus 1 whole square divided by 2 times of x square plus 1 sigi whole square tarane left to right to square loba kanda koina x square plus 1 gi square haiba ma atopa mana 2 times of x square plus 1 gi square haiba phange ko sumain taraga koina so tarani. Next question is Next question is question number 13. Find the modulus and argument of the complex number 1 plus 2i divided by 1 minus 3i. The piriba complex number is the division of two complex number the pireko. Sigi modulus ka argument ga putokpa. Modulus ka argument ga putoktring gi mamang that nangi expression jahana simplest form the easy ko. First rationalize this complex number 1 plus 3i by multiplying denominator and numerator by 1 plus 3i. For numerator, find the product of these two complex number. 1 multiplied by 1 plus 3i 1, 3i tareko. 2i na multiply already 2i plus 6i square. I into I is equal to I square. Then for denominator, 1 plus 3i 1 minus 3i is of the form a square minus b square की form the a plus b into a minus b ne the a square minus b square tareko. And is the real part imaginary part separate or 6i square is equal to minus 1. 1 minus 6 is equal to minus 5i. 3i plus 2i is equal to 5i. And 1 plus 9. 9 the 10 tareko. Then this minus 5 divided by 10 plus 5i by 10 minus 1 by 2 plus 1 by 2 gi I tare. Nangi complex number se standard form the reduced tareko. Standard form sina real part ni sina kaino imaginary part tare. Let this complex number minus 1 by 2 plus 1 by 2i be equal to x plus iy. Chigamana hale. Then write x is equal to minus 1 by 2, y is equal to 1 by 2. X in a real part, y in a imaginary part tare ko. Then find the modulus of z. Modulus of z is given by root over real part square plus imaginary part square, which is equal to 1 by 2 plus 1 by 4 plus 1 by 4 tare. Plus taugnaradi 2 by 4. The 2 cancel tauraga 1 by 2 square root. 1 by root 2 se phange ko. 1 by root 2 is the modulus of the complex number z. Nangi complex number z sigi modulus pire. Now we are going to find argument. Argument puthokadaba. First find tan alpha. Tan alpha is given by modulus of y divided by modulus of x. 1 by 2, 1 by 2, 1 tare ko. Therefore, alpha is equal to pi by 4. Tan की value the 1 dava se kya data hai 45 data hai ko. But in radian, value of alpha is pi by 4. Since the point P, whose coordinate x comma y, x haibasina nangi value se sida minus 1 by 2, y की value sina 1 by 2 tare ko. X की value से minus 1 by 2 ने, y की value से 1 by 2 ने. Lies in second quadrant. Second quadrant दा लाइग्रे. Second quadrant दा लाइरगदी nangi argument से कहीं ना pi minus alpha है बदु ना p गिद्रा. So pi is equal to pi minus pi by 4 तारे को. अनि से कोई ना subtract तोंग ना बमतम दा 3 pi by 4 फांगे. Nangi complex number से गी argument से ना 1 by root 2 तारे को. अदुगा nangi कैदोगा sina modulus ni ko. Argument habi sina kay na pira 3 pi by 4. Si mamang da koy na tam graba ngakta ni ko. Miscellaneous study pula mix up tawraga question si yauksin by 1. Next question is question number 14. Find the real number x and y if x minus iy into 3 plus 5i is the conjugate of minus 6 minus 24i. X in x minus iy ga 3 plus 5iy ga gi product se si kanagi conjugate no, which is the conjugate of the complex number minus 6 minus 24i. Then find the real number x and y. X ka y ga gi value se puthokadaba ko. For question number 16, it is given that the product of these two complex number is the conjugate of minus 6 minus 24i. This bar represents the conjugate of minus 6 minus 24i. Find the conjugate of this complex number. Conjugate of this complex number is minus 6. Minus sign will be changed into plus 24i. Minus 6 khatang plus the sign tawgani. Conjugate lobo se real part is same hoigani, imaginary part the sign change tawgani ko. Then find the product of these two complex number. 3x, 5xi, 3i, 3yi minus plus minus tare ko. 5y value I into I is equal to I square. Minus 6 plus 24i. 3x I square gi minus 1 nama minus minus plus tare ko plus 5x minus I common lꯧꯊꯣꯛ ꯇꯥꯔꯗꯤ 3i ꯇꯥꯔꯦ ꯁꯤ real ꯁꯣꯝꯗꯁꯨ complex number ꯑꯃ ꯐꯪꯉꯦ ꯁꯣꯝꯗꯁꯨ complex number ꯑꯃ ꯐꯪꯉꯦꯀꯣ ꯑꯗꯨꯗꯤ complex number ꯑꯅꯤꯁꯤ ꯅꯪ equate ꯇꯧ ꯇꯥꯔꯦ equating real part and imaginary parts by equating these two complex number equate tꯧꯔꯦꯀꯣ real part imaginary part equate ꯇꯧꯕ ꯃꯇꯝꯗ 3x plus 5y is equal to minus 6 and 5x minus 3y is equal to 24. We have two equations, first equation and second equation, involving two variable x and y. Equation 1 ga 2 ga use tawraga nangna xy puthoktoiniko. First check the coefficient of x and y. X and y coefficient check tawra manabra ni se manade multiple oinabra oinade ko adudi kaidawni koina multiplying equation number 1 by 5 and equation number 2 by 3 15 tanaba semani ko. We get 15x plus 25y is equal to minus 33 na multiply to 15x minus 9y is equal to 72 and subtract na siko minus sign do the sign sing se change to plus a minus in a plus in a minus change to 25 the 9 halves in 34y ko minus 30 plus minus 72 is equal to minus 102. Then dividing both sides by 34, we get value of y is equal to minus 3. Now, si y ki value phange, y ki value sa kya hoina phange? Minus 3 hoina phange ko. Then by putting this value of y in either equation number 1 or equation number 2. 1 natraga 2 da hapo. 1 natraga 2 da hapa matamda nangi 3x plus 5y se minus 6. Nangi equation 1 do in hape ko. 1 da hape which implies that 3x plus 5 into minus 3 is equal to minus 6. 3x laser segi 5 siga minus 3 siga di 15 tare ko. Minus 6 plus 15 is equal to 9 which implies that value of x is equal to 3. So that koina 3 na divide out to ani. Aduga nang na husik x ki value sina 3 oina phange, y ki value sina minus 3 oina phange ko. Next question, question number 16. If x plus iy whole cube is equal to u plus ib, x plus iy whole cube is equal to u plus ib, then show that u by x plus b by y is equal to 4 times of x square minus y square. Now on the house p is a x plus iy whole, we shall prove that u by x plus b by y is equal to 4 times of x square minus y square niko. Now x plus iy whole cube expand to x cube plus 3 times of x square iy plus 3x, write the square of second term iy square and write iy whole cube is equal to u plus ib tare ko. X cube 3x square yi, value of I square is equal to minus 1 and we have 3x y square I cube. I cube is reduced to I square into I and write I cube y cube is equal to u plus ib. A plus b whole cube ki formula expand tawraga koina a square se amuka reduce tawbai wani ko. So the real part and imaginary part separate tawsi ko. Value of I square minus 1 tani dana minus 1 tare. Aduga sida I yaudaba khando I yaudaba se x cube minus 3x y square haibama I yaubasina 3x square y minus y cube haibama. Second term siga fourth kasina I yaure, first ka third kasina I yaudre ko is equal to u plus ib. So main taraga nangi real part and imaginary part haina tungan khaidoi. Next, equating real part and imaginary part. Nangi real part ka imaginary part ka equate tawsi ko. Si equate tawba matamda x cube minus 3 times of xy square se. Siki real part siga u ga manarani. Imaginary part will be equal to b. Si phange ko then write expression of left hand side. Left hand side si ito se u divided by x plus b divided by y is equal to write u. U is x cube minus 3xy square by x phange ko plus then b is equal to 3x square y minus y cube divided by y. Chikai common y. X common y ko x common oraga x na divide to the x cube divided by x is x square. Then we get 3y square. 3x square y by y is 3x square y cube divided by y is equal to minus y square. Then find the sum of like terms. X cube x square plus 3 times of x square is 4 times of x square. Minus 3y square plus minus y square is equal to minus 4y square. Taking 4 common from these terms, we get 4 into x square minus y square. And so left hand side is equal to, nangi left hand side se kai ga manare, right hand side have siga manare ko. Last question. Question number 20. If 1 plus I divided by 1 minus I whole to the power m is equal to 1, then find the least positive integral value of m. Integral haibadi integer niko. Adu positive oigada 1 plus I divided by 1 minus I whole to the power m se 1 tare. We have 1 plus I divided by 1 minus I whole to the power m is equal to 1. 1 oireko. First rationalize this complex number. 1 minus I then rationalize the. For this, we have to multiply denominator and numerator by 1 plus I. 1 plus I whole square by 1 plus I into 1 minus I whole to the power m. 1 tare ko. Si expand to 1 square 2 times of I plus I square. And denominator is 1 square minus I square is equal to 1. Which implies that I square gi minus 1 am thorakani ko. Minus 1 to go 1 ga kakna garadi 2i fange. Sigi 1 ama. I square gi minus 1 ama minus minus plus 2 tare ko. Then this 2i divided by 2 we get 1 pangdra. 2 to kakna garadi I lem hore. I to the power m is equal to 1 pange ko. I gi power m's the 1 daradi. Write all the possible values of m haibane. The possible values of m I square se minus 1 ni ko. Sida amuka squaring lawradi minus 1 whole square ni minus 1 whole square di kai tagre plus 1 tare dena. Aduna I gi value na I gi value na plus 1 tabasegi list value se kai de hore 4 dagi hore ko adugi 4 gi multiple de ma se kai taramane 1 taramane but therefore the possible values of m are m is equal to 4, 8, 12. They are multiples of 4 gi multiple de dun chatlani ba ko. And hence the least positive integral value of m is sigi value ma'am sidagi khwai dagi apik pa m gi value hang tar di kai tare 4 tare ko. 4 is the least positive integral value of m in which I to the power m is equal to 1 tab. Smain taraga koina question 20 se solve torani. For today let's end here.